Okay, I just want to kind of show this because this is actually mind-blowing. I built this literally like this afternoon after coming home here for the last few hours. And so the idea is basically that I implemented a system that allows to control keep safe through natural language in English. So don't ignore this all here. So it's like open keep safe and go to the settings and turn on backup. So let's see what it does here. I just had backup turn off. It's still a little slow. I'm sure there's ways to make this faster, but here it says I got mapping out the steps. So start the app, navigating to backup settings, enable backup toggle, and capture screenshot to verify everything is and works. So it turns off the emulator. So now it opens keep safe. Taps in the pin just to kind of make sure this is not a UI test. This is really the LLM navigating the emulator, and I can show you in a second on the level of stuff I did in between to know where it needs to click. But it's basically a mix of knowing the app from processing the layouts and then dumping the screens and reading screenshots to know what to do. So let's see if it does. And it also goes to settings. And so now let's see if it finds backup. Now it's in backup and sync. Interesting, it tries to enable the backup button, but oh, here we go. Now backup is on. And now it dumps that screen and verifies that the backup is on. And so while we're at it, let's do the following too. While you're in the app, go also to settings and change the appearance from blue to yellow. Let's see if it does that without having to reopen it. It should be just working. So it goes to appearance settings navigation. Now it's in settings. Finding coordinates for yellow. So it views the image actually here. And based on the screenshot of that image, it now finds the position, coordinates 540. I guess that hasn't worked. Let's see if it does that. The system color is not yellow yet. You can verify that by seeing a check mark over the selected system color. It's currently blue. So, oh, now it clicked into yellow. Sweet. And figured that out. That's fucking amazing. So, why I thought about this is because when there's bugs coming in, this could be a very interesting way of like, one, reproducing bugs, reading the logs from bugs, but also just explaining what you want to solve in there yourself, right? So let's try this. Add a new album on the album screen called demo. Opens album, or it just types in demo now. This is all for the first time trying here. I mean, I've done this once or twice before, but this is all brand new. Demo, okay, cool. Now does it know that it needs to press done? Done. Oh, fantastic. And so I'm very sure with that, it's also able to just generate UI tests out of this that can be replayed and put into CI and all kinds of stuff. And maybe because we're here, let me just show you how I thought about this and actually went about this. So I made some other commits in the meantime. But at its core, I started with a brainstorm about how this could work and somehow extracting the information of the UI code to know what the screens are called, what they're good for, what the interaction elements are, and then being able to attach that to ADB and actually see what's on the screen and drive this. I didn't really know if ADB would be able to do this. I knew we could get logs and screenshots, but I didn't know the extent of interacting with a simulator. I also didn't have a simulator installed, so all of this was from scratch, right? So basically, how it's building this, it's building this like static atlas, which just maps everything that the app has to, I think it's a JSON file. And then it has this dynamic enrichment, which is basically capturing the actual state of the UI, meaning the full XML. This is like those long console outputs that we've seen. Here is basically, this is the capture, plus screenshots. Then I implement this Python driver that knows how to start activities, deep link, tap specific IDs, text, descriptions, and so forth. And so those commands is basically what the LLM interacts with. So it looks up in those static atlas what it wants to do and makes its planning, and then it uses the dynamic enrichment to just verify what it sees on the screen, and then this is the tool it uses to drive ADB, and then there's like an action mapper that maps all the things to what to do. Yeah, and so basically both static and dynamic. This had some clarifying questions. I kind of brainstormed a lot, and so this is kind of like the high-level spec. And then out of that high-level spec, I broke all of those implementation steps down into the individual implementation steps. So you can see here, this is the UI agent driver plan. So this is then again as a spec, but this is, as I said, much more detailed. So you can see this is exactly what it should do, the schemas, and it has a to-do list, and then the dynamic improvement. It didn't work right away, so I had 2-3 iterations on actually reflecting on it and improving. So those are the specs that on how this needs to be improved. This is another improvement, and this is how to write those static atlas from the UI. So it generates basically those JSON files for the different screens. I didn't verify those. I'm like, cool, this works for me. And so so this is basically the code. I had it record a video, so it can record videos. It just basically generates a video. It takes a lot of screenshots and then it generates a video automatically from those screenshots. I just asked it to do this. And so here you can see all those individual screens. I just need to find the right folder for this. Those need to be checked in because they're static, compiled. And anyhow, I'm just gonna put this in one commit and for you guys to check it out, and maybe it's helpful. I had sure fun building this over the last few hours, and I for sure feel if I would have given this to myself or to anyone to program this from scratch, this would have been a multi-week project, or to the point where it's impossible actually, because we wouldn't have been able to interpret English language.